66 million years ago, dinosaurs occupied every corner of a vibrant Cretaceous world. Then, in a single geological instant, their fossil record stops. This is the Cretaceous-Paleogene, or KPG, boundary. It is a distinct layer of dark clay compressed between lighter bands of rock found all over the globe. Below this dark line, the rock is packed with dinosaur fossils. Above it, there is absolute biological silence. For decades, scientists proposed gradual causes for this die-off, like creeping diseases or mammals stealing dinosaur eggs. But those theories couldn't explain why the disappearance happened so abruptly, everywhere on Earth simultaneously. In 1980, a physicist named Luis Alvarez and his geologist son Walter started analyzing the chemical makeup of that specific dark clay layer. They found concentrations of iridium hundreds of times higher than normal. Iridium is extremely rare on Earth's surface, but it is abundant in asteroids. That chemical signature reframed the extinction as a violent impact from space. The search was on for a crater nearly 100 miles wide. To prove the asteroid hypothesis, researchers needed to find the physical scar left by the collision, a crater large enough to have blanketed the entire globe in iridium dust. 10 years later, they found it, buried deep beneath Mexico's Yucatan Peninsula. Today, the coastal town of Chicxulub sits quietly right above the impact site. The crater is immense, featuring a multi-ring structure with a central peak ring, a common feature in the largest planetary impacts. In 2016, a scientific expedition drilled thousands of feet down into the submerged peak ring to extract physical rock cores. The rock they pulled up held a bizarre anomaly. The cores contained deep earth granite that had been shocked and melted, yet they completely lacked gypsum, a sulfate-rich rock normally abundant in this specific seapod region. The sheer heat of the impact instantly vaporized the rock, converting it into a sulfur-rich aerosol that reached the upper atmosphere. Thousands of miles north of the crater, in North Dakota, a site known as Tanis provides a minute-by-minute snapshot of the immediate aftermath. Excavators at Tanis uncovered a mass grave of fossilized fish piled tightly together. They had been violently and rapidly buried alive under a thick, concrete-like layer of sediment. When researchers looked closely, they found the fish's gills were clogged with tektites. These are tiny, glass-like spheres of molten rock that rained down from the sky immediately following the impact. The asteroid strike generated seismic shocks equivalent to a magnitude 11 earthquake. This triggered massive oscillating waves, known as seiche, in inland rivers and lakes, sloshing water and sediment over the local ecosystems in minutes. The Tanis fossils capture the exact moment the destruction arrived. It is the physical evidence of a shockwave and debris fallout that ripped across the continent before the dust had even settled. The object that struck the shallow sea was up to 15 kilometers wide. It hit Earth with the explosive yield of 1 billion nuclear bombs. The blast generated supersonic winds and global megatsunamis. Superheated debris was thrown into the upper atmosphere and rained back down, igniting continent-spanning wildfires. The deadlier phase came from the missing gypsum. The vaporized rock injected massive quantities of sulfur aerosols into the stratosphere. Combined with the soot from the fires, this thick atmospheric cloud quickly encircled the globe. The Earth went dark. Global temperatures plummeted by tens of degrees, forcing the planet into a harsh, multi-year winter. Without sunlight, plants could no longer photosynthesize. The sudden thermal shock and the atmospheric starvation broke the foundation of the ecosystem. Herbivores had no food, followed quickly by the carnivores, causing the systematic collapse of the food chain that doomed the non-avian dinosaurs. Even with the crater identified, the academic debate was far from over. A faction of scientists pointed to a different culprit, leading to a fiercely contested period known as the Dinosaur Wars. Their evidence was the Deccan Traps. This is a region in western India covered in roughly 1.3 million square kilometers of volcanic flood basalts, formed by massive, prolonged eruptions that released immense amounts of climate-modifying gases. Researchers argued intensely over whether the sudden asteroid strike or the gradual choking from these volcanic gases was the primary driver of the ecological collapse. Recently, a team of researchers from UC Berkeley proposed a unifying model. They realized these two events were not a coincidence, but were physically linked. They calculated that the immense seismic energy from the Chicxulub Impact traveled through the Earth and triggered a massive escalation in the Deccan Traps eruptions. The extinction was a 1-2 punch of an extraterrestrial strike immediately followed by intense terrestrial volcanism. The biological toll of this dual catastrophe was absolute. The large, dominant dinosaur species that had ruled the continents for over 100 million years were completely erased. This chart shows the fossil record directly above the boundary. The species that survived were the ones that could adapt to a ruined, darkened world: freshwater organisms, avian dinosaurs, and small mammals. With the massive apex predators gone, a vast biological vacuum opened up. Those surviving mammals emerged from the darkness to inherit and repopulate a newly emptied environment. Uncovering the violent end of the dinosaurs reveals the catastrophic, fiery origin story of our own mammalian dominance.